Welcome to your Algebra 2 6.5 and 6.6 lesson. The first video will be lesson 6.5 and the second lesson will be 6.6. For 6.5 you're going to learn how to graph square root and cube root functions. The parent function for the family of square root functions is f of x equals square root of x, just plain old y equals square root of x. The domain is going to be x greater than 0 because if x is less than 0 you're going to be generating imaginary numbers and that's not what we want. And the range is going to be y greater than or equal to 0. So here, if you look down here, we've got the square root parent function, y equals square root of x. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So those are great critical values for you to keep in mind. You need to learn this overall pattern. The parent function for the family of cube root functions is g of x equals the cube root of x. The domain and range are all real numbers because the cube root of a negative number is just a negative number, so that's not a problem. Critical values here are going to be that the cube root of negative 8 is negative 2, the cube root of negative 1 is negative 1, cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2. Okay, we're going to graph y equals 1/2 square root of x and state the domain and range, and then we're going to compare the graph with the graph of y equals square root of x. Now, eventually we'll be able to just graph based on the pattern, but let's go ahead and make a table of values to be able to graph y equals 1/2 square root of x. So you just, x has to be greater than or equal to 0 because we're dealing with square roots. So we pick x values greater than or equal to 0. So let's start at 0 and then do 1, 2, 3, and 4. If you take the square root of x and then multiply by 1/2, you're going to get 0, 0.5, 0.71, 0.87, and 1. And so then you just plot your ordered pairs. So 0, 0, 1, and then 0.5, 2, 0.71, 3, 0.87, and 4, 1. And then go ahead and draw in our function of interest and then dot in y equals square root of x. Okay, or draw it in really lightly so you can make a comparison. Okay, they have the same domain, so x greater than or equal to 0, same range, y greater than or equal to 0. Okay. The only thing is that all our y values for y equals 1/2 square root of x are exactly 1/2 the y values of y equals square root of x. And so we call that a vertical shrink of the graph by a factor of 1/2. So if you have a coefficient out here in front of your square root of x, that's going to tell you the factor by which you either vertically shrink it if it's has an absolute value between 0 and 1, or stretch it if it has an absolute value greater than 1. Do you remember what happens if you have something like this and you have a negative coefficient? That's right, it flips the function. So you have a flip or reflection across the x-axis. Let's see one like that. We're going to graph y equals negative 3 cube root of x and state the domain and range, and then we're going to compare the graph with the graph of y equals cube root of x. Okay, so let's make our little table of values. We can use positives and negatives for cube roots. So let's do negative 2, negative 1, 0, 1, and 2. And then let's take the cube root of x and multiply by negative 3. So the cube root of negative 2 multiplied by negative 3 is going to give you positive 3.78. The cube root of negative 1 is negative 1 times negative 3 is 3. Cube root of 0 is 0 times negative 3 is 0. Cube root of 1 is 1 times negative 3 is negative 3. Then you take the cube root of 2 and multiply by negative 3 and you get negative 3.78. So here in red, you can see our points that have been plotted, and here's y equals negative 3 times the cube root of x. And then we want to sketch in y equals cube root of x. I like to use dotted lines or dotted curves, for my parent functions. You can just do it really lightly if you'd like. All right, keep in mind that negative 1, x equals negative 1, is going to give you a y value of negative 1 because the cube root of negative 1 is negative 1. Cube root of 0 is 0, and cube root of 1 is 1. And so those critical values can help you, or important values can help you sketch in y equals cube root of x. All right. So the domain and range are all real numbers because we can plot plug in negative values as well as positive, and we can generate negative values as well as positive. 0 is fine. The graph of y equals -3 times the cube root of x is going to be a vertical stretch by a factor of 3 because the absolute value of that coefficient is 3, followed by a reflection in the x-axis or across the x-axis because of the negative. All right, let's generalize even more because we've looked at stretches and shrinks and reflections, but what about translation slides? Well, to graph y equals a times the square root of x minus h plus k, or y equals a times the cube root of x minus h plus k, follow the steps below. We're going to sketch the graph of y equals a times square root of x, or y equals a times cube root of x. That's what we did in examples 1 and 2. Then we're going to translate the graph h units horizontally and k units vertically. So we're going to graph y equals -2 times the square root of x minus 3 plus 2, and then we're going to state the domain and range. So first thing we do is we sketch the graph of y equals -2 times the square root of x. It's shown in blue here. So square root of 0 is 0 times -2 is 0. Square root of 1 is 1 times -2 is -2, so we have 1 -2. The square root of 4 is 2 times -2 is -4. Okay, and so there is y equals -2 times the square root of x. Okay, now we want to do our translation. So h is 3 and k is 2, because remember this is x minus h. So h is 3, so that means we need to take each one of these points and we need to move them 3 units to the right and 2 units up. And then we just sketch in our final function. So we're going to take 0, 0. We're going to move 3 units to the right, 2 units up to 3, 2. We're going to take 1, -2. We're going to move 3 units to the right and up 2 to 4, 0. And we're going to take -4, -4, and we're going to move 3 units to the right and up 2. And you can see that point is just right there. And so we draw in our final function. It's going to be very important that you label these so I know which is your final answer. So what's our domain and range? Well, we can get that from our graph. If you look, the x values start here at 3 and then go to the right, so it's going to be x greater than or equal to 3. The y values are here at 2 and then get smaller, so y less than or equal to 2. Okay, so x greater than or equal to 3 because it starts at 3 and we go to the right. Y less than or equal to 2 because we start at 2 and we go down. Okay. All right, let's look at the graph of y equals 3 times the cube root of x plus 4 minus 1, and we're going to state the domain and range. So first thing we want to do is graph y equals 3 times the cube root of x, and so that's here in blue. Okay, so cube root of -1 is -1 times 3 is -3. Cube root of 0, 0 times 3 is 0. Cube root of 1 is 1 times 3 is 3. So here we have y equals 3 times the cube root of x. Now we want to translate this whole thing. Let's see. X plus 4 is the same thing as x minus -4. So h is -4. Then we have -1, so k is -1. So we need to translate left 4 and down 1. So let's change that to say down 1. That's going to bug me. All right. So here we go. So we're going to do left 4 and down 1. So we go to the left 4. So 1, 2, 3, 4, and down 1. So we move 1, 3 to -3, 2. For 0, 0, we're going to go left 4, 1, 2, 3, 4, and down 1 to -4, -1. For -1, -3, we're going to go left 4 and down 1 to -5, -4. And that is our final function of y equals 3 times the cube root of x plus 4 minus 1. From the graph, you can see that the domain and range of both functions are all real numbers. We can plug in any x value we want, and we're going to generate all kinds of y values. We're going to have negatives, positives, zeros. So the domain and range are both all real numbers. Okay, that's it for lesson 6.5. I'll meet you right back here for the 6.6 portion of the lesson.